Good morning to everyone who's watching us live. We are from class Andromeda and our subject matter for today is solving situational problems involving trigonometric equations. Let's get into it.
After studying this course, you should be familiarized with and solve situational problems involving trigonometric equations on your own.
Before getting any further, we should first borrow wisdom from the great Hungarian mathematician George Polya on solving any situational problem. Polya defined mathematical problem solving as finding a way around a difficulty around an obstacle and finding a solution to a problem that is unknown.
Before we get down to the nitty-gritty, we'll first briefly discuss George Polya's 4-step rule in problem solving. The first step is to understand the problem. To show an understanding of the problem, you, of course, need to read the problem carefully. Sounds simple enough, but some people act hastily and start solving the problem before they've read the whole problem.
The second step is to devise a plan. When you make plans, you find a way to solve the problem. Guessing and checking, looking for a pattern, drawing a picture, using a formula, eliminating possibilities, using a model, and the likes are ways that you can go about solving your problem.
The third step is to execute the plan. This step is usually easier than devising the plan. In general, all you need is care and patience, given that you have the necessary skills. Persist with the strategy that you have chosen. If it continues not to work, discard it and choose another. Don't be muzzled. This is how mathematics is done, even by professionals.
Lastly, check to see if you used all your information and that the answer makes sense. If your result checks out, make sure you write your final answer with the correct labeling.
With all that wisdom acquired, we should now be ready to tackle trigonometric equations in the real world. And what better way to learn to solve situation problems than using practice problems? According to Aristotle, excellence is not an art, it is the habit of practice.
It is important to note that these situational problems involving trigonometric equations will already have models in them. This lesson won't cover all types of situational problems, nor how to make a model when not provided one, since our goal stated at the beginning of this course is to get you familiar with situational predicaments involving trigonometric equations. We would only be providing lucid word problems that everyone can follow along. Now that we got that out of the way, we'll proceed with our problem-solving walkthrough, starting with Rodel.
First problem involving trigonometric equation is us helping Raul find out the average monthly sale for his heating oil. Raul's heating oil is very seasonal, with the sales in the winter for exceeding in the summer. Monthly sales can be modeled by S of x equals 1,600 cosine pi over 6x minus pi over 12 plus 5,100, where S of x is the average monthly sales in the month x. What is the monthly average sales for July? Considering that January is x equals to 1, we can say that July is x equals to 7. First, write the equation, which is S of x equals to 1,600 cosine pi over 6x minus pi over 12 plus 5,100. Then substitute x by 7. Then we multiply 7 by pi over 6. We simplify 7 pi over 6 minus pi over 12. Then we subtract 14 pi by pi. After that, we convert 13 pi by 12 to degree mode by multiplying it 180 over pi, leaving us with 195 degrees. Then we solve for cosine 195 using our calculator, getting negative 0.97. Then we multiply 1,600 by negative 0.97 and we add 5,100 to the product, leaving us with our final answer, 3,548. Therefore, we can calculate that the monthly average sales for July is 3,548 pesos.
The second on the list is determining the average monthly temperature of the water in a mountain stream on a certain month, and in this case, it's October. The average monthly temperature of the water in a mountain stream is modeled by the equation T of x is equal to 19 sine multiplied by the quantity of pi over 6 x minus pi over 2 plus 53, wherein T of x is the average monthly temperature in degree Fahrenheit and x being the month. Considering that January is equal to 1 or x equals 1, then we can say that October is equal to 10 or x equals 10. To solve for the problem, first we would need to write the equation T of x is equal to 19 sine multiplied by the quantity of pi over 6x minus pi over 2 plus 53. Then we substitute the values of x, which is 10. Then we would multiply pi over 6 by 10, which would give us 10 pi over 6. Then, by using LCD, we simplify 10 pi over 6 minus pi over 2, giving us 10 pi minus 3 pi over 6. Then we simplify it again, giving us 7 pi over 6. After that, we would need to convert 7 pi over 6 to degree mode by multiplying 7 pi over 6 by 180 over pi, leaving us with 210 degrees. Next, we solve for sine 210 degrees by using our calculator, getting negative 0.5. Then we multiply 19 by negative 0.5 and we add 53 to the product, giving us 43.5 as our final answer. Therefore, we can conclude that the average monthly temperature of the mountain stream is 43.5 degree Fahrenheit.
The third problem on the list is determining the average monthly temperature in Phoenix, Arizona on a certain month. The average monthly temperature in Phoenix, Arizona can be modeled by the equation of f of x is equal to 19.5 cosine pi over 6 multiplied by the quantity of x minus 7 plus 70.5, where f of x is the average temperature in degree Fahrenheit and x in months. Considering that January is x is equal to 1, we can say that February is x is equals to 2. First, we write the equation of f of x is equal to 19.5 cosine pi over 6 is multiplied by the quantity of x minus 7 plus 70.5. We substitute x by 2. Then we subtract 2 by 7. And multiply the difference by pi over 6, giving no negative 5 pi over 6. Then, we convert negative 5 pi over 6 to degree mode by multiplying it to 180 over pi, leaving us with negative 50 degrees. Next, we solve for cosine negative 150 degree using our calculator, getting negative 0.87. Then, we multiply 19.5 by negative 0.87 and we add 70.5 to the product, leaving us with our final answer is 53.535. Therefore, we can conclude that the average monthly temperature for February in Phoenix, Arizona is 53.535 degree Fahrenheit.
Our last problem involves finding the average monthly sales of Mary and Addie's Christmas tree. Mary and Addie's Christmas tree is seasonal, with winter sales greatly exceeding summer sales. Sales on a monthly basis can be modeled by m of x equals to 1430 cosine of pi over 6x minus pi over 12 plus 5,000, where m of x is the average monthly sales for November. Note that January is x is equals to 1. Considering that January is x is equals to 1, then we can say that November is x equals to 11. First, write the equation, which is m of x is equals to 1430 cosine of pi over 6x minus pi over 12 plus 5,000. Then we substitute x by 11. Then we multiply pi over 6 by 11. And then we simplify 11 pi over 6 minus pi over 12 by finding the LCD and giving us 21 pi over 12. After that, we convert 21 pi over 12 into degree mode by multiplying 180 over pi to it, giving us 315 degrees. Then we solve for cosine 315 degrees using our calculator, giving us 0.71. And we multiply 1430 by 0.71 and adding 5,000 to the product, leaving us with 6,015.3. Therefore, we can conclude that Mary and Addie's monthly average sales for the Christmas tree for November is 6,015 pesos and 3 centavos.
Now you try it. Try to solve this problem on your own. The river leading to Iraya's hydroelectric power plant has an average monthly temperature that can be represented by the model R of x is equal to 24 sine multiplied by the quantity of pi over 6x minus pi over 2 plus 48, where R of x is the temperature in degree Fahrenheit of the water in the month x. What is the temperature in May? Note that January is x equals to 1.
And that is all we have for you in this lesson. We sincerely appreciate your attention today. Thank you, stay safe, and God bless.